In today's episode, we'll be discussing the science of sound and hear some of the first ever recordings from Mars. Before we begin, a few announcements. There are now new ways to keep up with the podcast. Blinded by Science is now on Twitter and Instagram. Follow for the latest episodes, updates, and of course, science. The podcast also has a website now where you can get episode notes, script notes, images, and more. Links to all of these are in the description in today's episode. Follow the show at these locations to get the latest episodes and updates. And now let's begin the show, but first, a quick word from our sponsor. Welcome to Blinded by Science, a podcast appreciating all things science. I'm your host, Anthony Nanfito, sci-fi writer and educator. But for this podcast, you can think of me as your science ambassador. I'm fascinated with the scientific process, the knowledge it reveals to us, and I want to share my appreciation of it with the world. Now, let's get to the science. Sound is a fundamental part of life on Earth. For most creatures, but not all, it is a matter of life and death. Sound is energy produced when objects vibrate, and these vibrations travel through mediums such as air, liquids, and solids. For example, my larynx, or voice box, is producing vibrations to create the sounds that make up this sentence. These vibrations are then picked up or measured by the microphone, and they are stored as digital information to an audio file on my computer. I then take that audio file and upload it to a podcast host server, which is then accessed by you, the listener. And the same sound vibrations my voice box created are reproduced by your speakers or headphones. Whew. Okay, that was a lot, so let's unpack that. As I mentioned before, sound is energy, and it's produced when objects vibrate. Those vibrations can be measured and visualized as waves. Sound waves behave in a similar way to light waves, but with one important distinction. Light can travel within a vacuum, but sound cannot. Remember, sound is energy produced by objects vibrating. That means there needs to be a certain density of objects, such as air molecules, to vibrate in order to produce sound. In a vacuum, this density does not exist. Hence why some people get a little irritated when certain science fiction movies or TV shows have explosion sounds in space. Space is a vacuum, and this wouldn't happen in real life. For a more realistic space battle, consider pressing the mute button during this battle scenes the next time you watch your favorite space opera. Sorry to suck the air out of the room, but that galactic elephant needed to be acknowledged. Grab your surfboards because it's time to ride the waves. Sound waves, that is. So maybe not a surfboard, but just your headphones. Grab your headphones. There are two kinds of waves: longitudinal and transverse. Longitudinal waves are waves of energy created when the source of vibration or disturbance moves in the same direction as the wave. This is how a sound wave works. When you hear a sound, you can trace it back to its source because of the property of longitudinal waves. Transverse waves are waves of energy created when the source of the vibration or disturbance moves perpendicular, or at a 90-degree angle, to the wave. These are often associated with the up and down motion of ocean waves. Those are the ones you can use your surfboard for. If you're looking for a visual demonstration of this, I recommend you check out NASA's Science of Sound website, linked in the description. They've got a series of 1-minute videos that break down the types of waves. As part of the demonstration, they use a slinky to represent the longitudinal waves and a rope that is moved up and down for the transverse waves. Regardless of the type of wave, we can take measurements of their energy vibrations. We can measure their wavelength, amplitude, and frequency. When sound waves move through a medium such as air, they bump into air molecules, which cause them to bunch together in some places and spread out in others. This creates an alternating pattern of squashed areas, known as compressions, and stretched out areas, known as rarefactions. The distance between compression to compression, or rarefaction to rarefaction, determines the wavelength. The amplitude is determined by the distance between the peak of the wave, or compression, and the midpoint between two compressions. This distance affects the volume. The larger the amplitude, the louder the sound. When we say frequency, we mean the number of compressions that pass through a single point or period of time. In other words, let's set the period of time to be 1 second. We want to measure how many compressions occur in that second. That number is the frequency for that sound and is measured in hertz, named after Heinrich Rudolf Hertz, the first person to provide conclusive proof of existence of electromagnetic waves. Side note, to German-speaking listeners, please let me know how I did with that pronunciation. I've never studied the German language formally, but I did make an honest effort, watch some videos, and practice. However, I apologize if that was insufficient and I completely butchered it. This information, the wavelength, the amplitude, the frequency, is what allows the sound from my voice to be transferred into the microphone and to your speakers or headphones. In essence, a microphone is simply a vibrational energy measurement device, and speakers or headphones are vibrational energy producers, each calibrated for the types of sounds that will be recorded or produced. Coming from your speakers and headphones, this sound energy then vibrates small hairs inside your ears. In fact, you can think of your ears as vibrational energy measurement devices like a microphone. And when your ears pick up these energy vibrations, it sends a signal to your brain. And your brain takes that signal and translates it into the thoughts, words, etc. that we associate with sounds. Now, humans can only hear a certain range of frequency of sounds. Generally, we can hear between 20 and 20,000 hertz. Compared with some animals, this is a limited range. For example, dogs and cats generally can hear up to 45,000 hertz, and the bottlenose dolphin can hear up to 150,000 hertz. Thankfully, we humans practice science, which allows us to create new technologies to hear sounds that we would not be able to hear with our own ears. Which leads us to the exciting topic of the sounds of Mars. We'll check out these Martian energy waves in today's segment of Science Did What? After a quick break. Hey, it's Anthony here. Thanks so much for listening to the show. Science is all about collaboration. If you've enjoyed what you've heard on the show, share it with a friend so they can enjoy it too. Science is all about sharing and keeping others up to date. All right, let's get back to the show. I know what you're thinking. Anthony, why are we at the ocean? You said we'd be hearing sounds of Mars in this segment, and the Martian oceans don't exist anymore. Well, you're correct, but the ocean recording connects to today's topic. We are going to talk about the amazing science that NASA is conducting with the recently landed Mars rover, Perseverance. But first, I wanted to ground you here on Earth. I played that recording so that you can remind yourself of how it sounds on our home planet before we head over to the red planet. In the first segment, I talked about how sound is vibrational energy. It moves through mediums, such as air, liquid, or solids. Here's what we need to make note of. Earth and Mars have very different atmospheres, temperature, and chemistry. While the two planets do have some similarities, they are different. And those differences are important, especially in this episode about sound. When sound travels through a medium like the air on Earth or on Mars, the density, the chemical makeup, the temperature will all have an effect on the sound waves as they travel through it. For this segment, I recommend headphones so you can hear everything more clearly than listening from a speaker. All right, let's pack our virtual bags and take a virtual trip to Mars so we can hear how things would sound differently on the red planet. The audio clips in this segment are all courtesy of NASA, and I highly recommend you check out the links in the description to NASA's Sounds of Mars website, because they include a number of comparisons between Earth and Mars. I'll play a few of them for you here, and then we'll hear some actual recordings from the Perseverance rover on Mars. So let's play that clip of Earth's ocean again. Now, I'll play a modified version of that clip. This is how the ocean waves would sound on Mars if it still had oceans. Okay, you can go back and replay that if you need to, but you probably noticed that the ocean sound on Mars sounded a bit muffled. That is because of those atmospheric differences I talked about earlier. In fact, most high-pitched sounds are difficult or impossible to hear on Mars. Think of sounds like birds chirping, or whistles, or bells. To demonstrate this, let's take a listen to two other examples. And again, the Martian version will sound more muffled than the Earthling version, so don't panic and think something is wrong with your headphones. First, let's listen to the sound of a bicycle bell on Earth. Now, let's listen to the sound of a bicycle bell on Mars. Next, the sound of a truck backing up on Earth. And now, the sound of a truck backing up on Mars. Do you hear the difference? All right, so those sounds are pretty cool. But what if hypothetically humans could breathe the atmosphere on Mars without the need of an environmental suit? And we're able to talk to each other? What would that sound like? Or in the alternative, let's say there were some Martian astronauts and they were listening to an amazing science podcast from Earth via a Bluetooth speaker. How would it sound? Well, let's use some famous words as an example. Here's how those famous words would sound on Earth, or in the case of this recording, a recreation of Earth's atmosphere within a spacesuit.
It's one small step for man, one giant leap for mankind.
In case you don't know who that was, that is a recording of Neil Armstrong as he took his first steps on the moon in 1969. Now, for the sake of this episode, let's say Neil Armstrong was on Mars when he said those words. Again, assuming he was able to breathe the atmosphere. This is how those same words would sound.
It's one small step for man, one giant leap for mankind.
Please note, NASA and other space agencies have yet to find any evidence of bicycles, trucks, or Neil Armstrong's disembodied voice on Mars. Again, your headphones aren't malfunctioning. The different atmosphere on Mars has a direct effect on how sound waves travel. In fact, the difference even goes as far to affect the speed of sound. So, those recordings were modified here on Earth based on our understanding of how sound works. We've been studying Mars for decades now, and we have a firm understanding of what its atmosphere is like. So, we can use that knowledge to extrapolate what sounds might sound like on Mars. That's how NASA developed these recordings. However, we all know it's not the same thing as experiencing it for ourselves. With the latest addition to the rovers on Mars, NASA did the unprecedented. It added 2 microphones to the Perseverance rover. One microphone was used to capture the entry, landing, and descent of the rover, and the other will be used for scientific research. Let's take a listen to what Perseverance has recorded so far. Before the rover arrived at Mars, it spent about 9 months traveling through interstellar space. Here's a recording from Perseverance's EDL microphone during that time period. The whirring you hear is the rover's heat rejection fluid pump. I know what you're thinking. Anthony, you said sound can't travel in the vacuum of space. How is this recording possible? That's because the rover isn't just flying through space naked. It is enclosed in a canister which was pressurized here on Earth, so it has an atmosphere around it. Next, we'll hear 2 clips captured on the surface of Mars. In the first clip, you'll hear the raw audio file. The dominant whirring sound you'll hear is the rover itself. In the second clip, you'll hear the same audio file, but the rover sound is filtered out. Okay, now the filtered version. I'm not sure if you caught it, but you can hear some Martian wind in that clip. Congratulations on being some of the first humans to hear sound from another planet. I can't wait to see what other recordings and new discoveries Perseverance and NASA make because of these microphones. And someday, we'll have humans visit the red planet. We already heard what Neil Armstrong said when he landed on the moon. What do you think the first human will say when they land on Mars? Or what do you think they should say? Tell me what you think by recording a voice message at anchor.fm/blindedbyscience. Or send an email to blindedbysciencepodcast@gmail.com. And I'll share it on an upcoming episode. Don't forget your name and where to find you on social media. That's it for this episode of Blinded by Science. Follow the podcast on Twitter and Instagram for more updates. Thanks for listening to this episode of Blinded by Science. This podcast was written and produced by yours truly, Anthony Nanfito. The theme song is Crimson Fly by Huma Huma. The logo was designed by myself using the app Over with image credit to nasa.gov. If you liked what you heard, subscribe to the podcast on Anchor, Apple Podcasts, Spotify, or wherever you listen to podcasts. Creators like me work hard to create content you love. But in order to continue creating content, We need support from followers like you. If you're enjoying the show and want more episodes, you can support the show financially at buymeacoffee.com/wordsbyfifi. Contributions can be one-time, monthly, or yearly. Visit buymeacoffee.com/wordsbyfifi to learn more. You can keep up with the podcast on Twitter at BBSPod, on Instagram at Blinded by Science Podcast, or on the website blindedbysciencepodcast.wordpress.com. Until next time, thanks for listening and stay curious.